Hi everybody, this is the first lesson in our new unit, which is on naming compounds and writing formulas for compounds. This information, these notes have been uploaded to your OneNote notebook in a new chapter. It's 3 names and formulas. So if you go and open the PDF for that, you can follow along in the notes and take notes on your sheet as I go through this lesson. Today we're going to just do a quick lesson on how to write simple formulas for what are called binary ionic compounds. And I'll give you a brief overview of what an ionic compound would look like so you know how to pick it out. So for this do now question, what's the difference between an element and a compound? So we haven't gone over that vocabulary specifically yet, but if you think about like your periodic table, the periodic table is a periodic table of the elements. So that means that these are the simplest type of substances that you can have. You cannot break down an element into anything simpler. It's only made up of itself. So for example, something like carbon, it's only made up of carbon atoms. Or oxygen is only made up of oxygen atoms. Whereas a compound is when you have multiple types of atoms, multiple elements, 2 or more, and they're bonded together chemically. So something like water. Water is a compound. It contains hydrogen and oxygen, and they're bonded to each other. Carbon dioxide contains carbon and oxygens bonded together to make one singular unit. So there's your difference. We're going to be looking at how to write formulas for compounds, different types. You also need to have a periodic table handy so you can look at where these particular elements are located. Now for your metals, if you recall from junior high or maybe even living environment, you talked about this. If this is your rough outline of your periodic table, you have like a zigzag line that cuts across it about 3/4 of the way over. Your periodic table on your reference table has this zigzag line in a bolder font around certain elements. Any element to the left of that zigzag line is a metal. And any element to the right of that zigzag line is a nonmetal. So you're going to have to know that in order to complete the examples that we're going to be doing in this lesson and through the rest of this unit. So what we're going to be looking at today is just ionic compounds. Now, ionic compounds are only composed of metals and nonmetals. Okay, so you have to have a metal in that compound and a nonmetal in that compound. The ionic compounds can be binary, which means that they only contain 2 different elements, which that's what we're going to look at today. Or they could also have something called polyatomic ions, which are certain types of formulas that you would get from using a different reference table, and we'll get into that in class. So today we're just going to be looking at how to deal with binary ionic compounds. So what that means is the compounds we're looking at today only contain a single type of metal and a single type of nonmetal. So if you have a formula and you recognize that it is a binary ionic compound, so 2 elements, a metal and a nonmetal, that's what makes it ionic. When you are given the formula and you have to name it, you're going to name the metal first. The metal will have a positive charge in that ionic compound. We call that a cation. If you think the T looks like a positive sign, that's helpful. And we will name the nonmetal second. The nonmetal will have a negative charge to it. We call those an anion, so think there's an N there for negative. So the metal gets named first and the nonmetal gets named second, and then we change the ending of the compound's name to ide, I-D-E. Okay, so we'll always name the metal, name the nonmetal, and change the ending of that second word, that nonmetal's name, change the ending to I-D-E. We're never going to use any sort of prefix in that name to tell us how many of the element that we're working with. So you won't see anything like mono or di or tri or anything like that in these ionic compounds. So I'll work through a couple of these examples and then I'll post a couple questions for you to answer in this video. So if you were given this formula, for example, you need to be able to categorize the compound. If you can't categorize the compound properly as being ionic, you're kind of at a standstill. Okay, so how do I know this is ionic? Again, you want to have that periodic table out. Potassium is a metal, chlorine is a nonmetal. So right away I know that this is an ionic compound. When I name an ionic compound that only has two elements in it, I name the metal first, I name the nonmetal second, and I change the ending to "ide." So it's not potassium chlorine, it's potassium chloride. And once we go through some of these names, it's a little clunky at first because you're kind of getting used to a new language. But you'll find that as you go along, it kind of sounds right when you start to say these. Okay, so this next one, again, we know this is ionic because it contains a metal and a nonmetal. So the first name of this compound is magnesium. We never change the name of the first element. The second element is sulfur. Well, I could either say sulfuride or sulfide. So which one sounds better here? We're going to use sulfide. We use the first syllable of that nonmetal and then drop the rest of it and change it to ide. So chlorine, the first syllable was chlor, and we change the rest to ide. So the next one here, we have aluminum and we have nitrogen. So first name, aluminum. Now the last name, we're going to use the nitrogen, but we want to change the ending to "ide," and we want to just use the first syllable of nitrogen. So this is going to be nitride, okay, not nitrogenide, just nitride. This next one, again, metal and nonmetal. We name the metal sodium. Well, what if I don't know the name for that symbol? You'll look it up. There's no mistakes in here. All of the information you need for this entire unit is on your reference tables. So we have sodium, and then we have bromine. So just like we did with chlorine, we're going to change that ending. So instead it's going to be bromide. And this last one in this column, we have aluminum, and we have phosphorus. So we know it has to end in "ide," and then take the first syllable of phosphorus, which is phos. So we have phosphide here. Okay, and you'll get used to this as we keep going through it. So I'll do this first one in this next column and then give you the rest to do on your own. So this first one, again, we will recognize that it's a metal and a nonmetal. So this is aluminum. And then the last, that's fluorine. We're just going to say fluoride. There's no indication in this name that we're dealing with 3 fluorines in the compound. Okay, it's just fluoride. There's no tri in there. It's just name it, IDE. So now I'm going to have a box pop up and you'll name these next 4 compounds. Okay, so that is when you're given the formula, how you come up with the name. So now we have to look at the opposite. If you're given the name of the compound, how do you come up with the formula for it? Because there's nothing in the name that tells us how many of each element we need. So if I gave you this name of aluminum fluoride, and I asked you to write the formula for this, there's a specific method on how to answer this. There's nothing in these words that tells me how many aluminums I need in my formula or how many fluorines I need in my formula. So there's information on the periodic table that will help you. The deal with ionic compounds is that the formula for the compound overall has to be neutral. So the number of positively charged metal ions I have has to cancel out the number of negatively charged nonmetal ions I have. Okay, so positive and negative charges must cancel out because compounds are neutral overall. So the compound itself will be neutral. The quantity of positive charges and negative charges will balance each other out. There's no prefixes in these words to help me. So what we're going to do to figure this out is what's called the crisscross method. Any teacher that you'll work with in high school will use this method. So the way you'll do this, and again, you need to use the periodic table. If you are not referring to a periodic table, you will not get these right. Period, end of sentence. Okay? So what you're going to do is you're going to look at your periodic table, and if you look at your like the key on the periodic table for carbon, for example, it gives you, I don't even know the numbers that they give you, maybe like this. They give you numbers in the top right hand corner, and those are called, that says that they are selected oxidation states. So at this point in the year, what you would think of those as being are like the different charges that that particular element could make. Okay? So what you're going to do is you're going to take the oxidation state, you're going to look at the periodic table for that particular element, you're going to take the oxidation state of each element and you're going to crisscross them to get your formula. So I'm going to show you what to do here. What you're going to also remember here, and this is important, for your non-metal, your second element, if there's more than one oxidation state listed in the box for that element, you're going to use the oxidation number that's at the top. Okay? So let me show you how this works with aluminum and fluorine. So on your periodic table, look up find aluminum, look at the top right-hand corner, and you'll see that there's only one oxidation state listed there for aluminum. You're going to write that down next to the symbol. And then you go to fluorine. Fluorine has one oxidation state listed. We'll write that down. Now, the positive charge and the negative charge are not equal to one another. So if I have a compound that has one aluminum with a positive 3 charge and one fluorine with a negative 1 charge, those charges don't add up to 0. So my compound is not neutral. So the shortcut way of neutralizing this compound is what is referred to as this crisscross method. So what you're going to do is you're going to take the oxidation state of the metal, just the number, not the charge, take the number, and you're going to crisscross it over to become the quantity or the subscript of the non-metal. The subscript tells you how many. And then you'll take the oxidation state of the nonmetal and crisscross it over to become the quantity of the metal. Once you've done that, now you can rewrite the formula neatly and kind of clean it up. We do not put ones in formulas, like we don't write Al1, that's just understood if there's no number, that it's a 1 there. So the formula would be AlF3. So again, referring back to this name of aluminum fluoride, there's nothing in those words that tells me that it's 1 aluminum and 3 fluorines. The only way you can get this formula correct is by using the oxidation states. So here are some examples for when you're given the name, how to come up with the formula. Okay, so again, reference table handy, you need to look these up. So lithium fluoride. Lithium symbol is Li. Its oxidation state is +1. Fluorine is F. Its oxidation state is -1. This is a simple one because the positive charged metal and the negative charged nonmetal, the charges already add up to 0. I don't have to crisscross them at all. When they combine, if I do, it would be 1 and 1, so whatever. They combine in a 1-to-1 ratio to make a compound. Aluminum nitride. Aluminum is a +3. Now, if you look at nitrogen's box in the periodic table, it has like 7 different possible oxidation states listed. For the nonmetal, you're going to use the top number that's listed, which is -3. So again, for this example, the +3 and the -3 balance each other out to 0. So I don't have to crisscross this at all. It would just be AlN. Now, side note, if you did crisscross and you got Al3N3, you cannot leave it like that. You would have to reduce those subscripts down to their lowest ratio, which is the 1-to-1 ratio. So it's correct as ALN. Al3N3 is not correct. Calcium oxide. Calcium, oxidation state, +2. Oxygen, oxidation state, -2. So again, we're in the position where the positive charge and the negative charge cancel out to 0. So this would just be CaO. I did those three first just to show you how to cancel, that when they cancel out, you don't have to crisscross. Now, sodium sulfide. Sodium is Na. Its oxidation state is +1. Sulfide, well, that's sulfur. Sulfur has multiple oxidation states listed, but for nonmetals, we'll use the top number that's listed, which is -2. So now my charges do not cancel each other out. The +1 and the -2 do not balance out. So I need to crisscross the oxidation states in order to get my formula. So the 1 from the sodium gets placed next to the sulfur. The 2 from the sulfur gets placed next to the sodium. When I write my final formula, Na, 2 for the subscript, S for sulfur, and I do not need to include the 1 in the formula because 1s are understood. Magnesium bromide. Magnesium is Mg with a +2 oxidation state. Bromide is bromine, Br, and top oxidation state for bromine is -1. So again, my numbers don't add up to 0, so I have to crisscross. Drag the 2 over next to the bromine, drag the 1 over next to the magnesium, Mg, 1 which is understood, Br, 2. So what I'd like for you to do now is to answer the in the question that's going to pop up, I'd like for you to write the formulas for these compounds. You may have a feature in the text box that allows you to do a subscript. So it might look like this. It might be like a little button that allows you to select a subscript. I think there's a superscript one too. So if you're able to do that for your subscripts, like if you just tap that, it will make your numbers drop down to subscripts. If you can't, if you just make them full size and put them in the formula, I'll understand. So that was an introduction on naming and formula writing for binary ionic compounds. So the key takeaways here. An ionic compound, you're going to have a metal, which has a positive charge. You're going to have a nonmetal, which has a negative charge. The compounds that we just looked at are binary because every single one of these has 2 elements in it. You have one metal, one nonmetal, one metal, one nonmetal, one metal, one nonmetal, one metal, one nonmetal. We only have 2 different elements in it. When you are writing the name for a binary ionic compound, you just name the metal, name the nonmetal, and change the ending to "ide." If you want to get the formula for a binary ionic compound, you're going to crisscross the oxidation numbers from the periodic table in order to get your formula. Thanks for following along.